The countdown. All right, so we're going to go back a little bit. Lucas said, oh, we're going back into geometry? Yeah, we're going back into geometry a little bit. So these are some things that we've actually covered already. And let's see, can I close it? Close it. Didn't close. So these are some things that we've covered already. And I went ahead and had the key up here so that you guys can go ahead and just write down, fill in the blanks, so kind of speed us up a little bit. If you remember a mid-segment, and there's a picture that goes with it. So if you haven't filled in the picture, over here on the right-hand side, so that's the mid-segment. Right there. I'm going to make that a little bit smaller. There's the mid-segment right there. The mid-segment is the segment that joins two midpoints. So D and E in that picture are going to be the midpoints. And then perpendicular bisector is a line, segment, or array. It can be any of those. It doesn't have to be a line. That divides a segment into two equal pieces. Okay? But it does so at a perpendicular segment, meaning that it makes right angles. So this is the perpendicular bisector itself, and then it creates the congruent pieces. And you have to have the right angle there as well. So don't only just write down the words, make sure you're putting stuff on the picture as well, okay? Angle bisector, again, can be any of the line segment array that divides an angle in half. So angle A over here is being divided in half. This is the angle bisector, and then you get the two congruent pieces there. So an angle bisector. And a median, which we've not talked about, is a segment that connects a vertex to a midpoint. You still get the congruent parts out of that, it just comes from a different place. So just one of the differences between a median and a perpendicular bisector is that the perpendicular bisector has the right angle. The median does not have to have a right angle. So you notice, like down here, there's not a right angle right there. Okay, so median comes from the vertex B, and then so on the perpendicular bisector, you notice that it does not come from the angle; it just is there. It just kind of comes from nowhere. Just originates almost like out of space. Okay, so there's those four. And then to kind of, these are all new. We haven't talked about any of these. Okay, we're going to continue talking about them throughout the week and next week. So we got segment. An altitude is a segment that connects a vertex of a triangle to the opposite side and creates a right angle. So here it comes from the B and goes to the opposite side, makes the right angle, but does not create congruency. No congruencies on here, but it does have the right angle. Ooh, that didn't work. Right angle. So you got perpendicular bisector, median, and altitude all have very similar characteristics. It's almost like they share two characteristics with something else, or they share something with something else. But they're not. None of them are the same. The circumcenter, incenter, centroid, orthocenter, those are all points, okay? And they're going to look a lot alike. Oh, that's too much. They're going to look a lot alike. So, here, 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 here. But they all come from different things. So the circumcenter comes from perpendicular bisectors. The incenter comes from angle bisectors. The centroid comes from the medians, and the orthocenters come from the altitudes. The pictures show that. If you look at the pictures, like the point M kind of looks like the same point M in all of them. But as I view this up so that you can see it a little bit better, there we go. In the perpendicular bisectors one, you can see very faintly because they're really small. It's got the congruent marks on here. But when you get to the angle bisectors, it doesn't have those congruent marks on here. On the angle bisectors picture, it actually shows you the angles being bisected in the angle, but that's not shown up here in the perpendicular bisectors. Okay? Look a lot alike, but the given information on each picture is a little bit different. So that's what distinguishes them from the other. There's 4 different centers. They come from 4 different segments. So we'll scoot down. So here, the one that comes from the medians, you've got the congruent marks, but there's no right angle right here. Okay?
So it's perpendicular. Oh wait, it's I'm confused.
That's okay. We just started going over it. It's okay.
So it'd be the perpendicular bisectors if there was a right angle in the 2 congruent sides?
Exactly. Exactly. Because when you think about the word perpendicular bisectors, right? Perpendicular means right angle. There's your right angle. Bisect means cut in half. There's your 2 congruent marks right there. Yeah, exactly. That's probably the simplest one to kind of understand because the word itself, perpendicular bisectors, is literally telling you what you're supposed to be looking for. And it's okay to be confused on all of them right now. We've just started. See the perpendicular here, Tim? No, so it's not going to be perpendicular bisectors. Okay. That's the one that comes from the medians, and this is that's called the centroid. And then the altitudes, you do see right angles, but there's no congruent marks at all. So here you have the right angles, but you don't have any congruent marks. So each one, they're there. That's 3, that's why you can't really see. Look at there. Okay, it's really small on your paper, so it's pretty difficult to see. All right. So for the moment, really all you got to do is fill in the blanks. And we're going to spend the time talking about them over the next couple of days. If you look at the front of your packet, it's got it broken down day by day what we're doing. Okay, so we're spending an entire day on circumcenter, incenter, an entire day on median and centroid. Okay, and so you can see that we're not all trying to cram all this in one day. Right? So that's just kind of a vocabulary overview. So what we're doing today is we're going to talk about things we've already talked about, perpendicular and angle bisector, and a little bit of Pythagorean. All right, so no need to put your name anywhere. Perpendicular bisectors. All right, what's perpendicular? Right angle. Bisect? Cut in half, so 2 congruent pieces. All right. So that's what this is telling you here. Perpendicular bisector, equidistant from the endpoints. Okay. So what the theorem says is just, the perpendicular bisector will be equidistant here to here. That's the congruent marks. Okay. Sorry. So perpendicular bisector theorem, if a point lies on the perpendicular bisector of the segment, hit a point. So we just take a random point. So, all right. Here's the perpendicular bisector. It's that ray that's coming down through the middle, right? And if a point, what's a point look like? Just a dot, okay? Can I put the dot here? Yes or no? Yes or no? Yes? Okay. If a point lies on the perpendicular bisector, is that green point on the perpendicular bisector? Okay. Then it's equidistant from the endpoints, meaning it doesn't matter where you put it, this is going to be congruent to this. I could put that point anywhere along that perpendicular bisector and that would be true. So if we put a different point up here, called red, as long as it's on that perpendicular bisector, and we connect it to A and to B, then they would be congruent to each other. It wouldn't matter where you put it. Okay? So you call that point, do they have, no, call that point, let's get rid of the red, and we'll call it E. E. Then we'll make the statement down here that says AE, or AEA, we'll use EA, is congruent to what? That's supposed to be a congruent line. That's a little bit better. What would EA be congruent to? EB. So the reverse of that. That's what the converse means right here. The reverse of that says that, well, now C, see this point C? Well, it just happens to be equidistant to those two endpoints. So what does that make? That right there. Well, earlier this was a perpendicular bisector. Is it a perpendicular bisector now? As long as you're at a right angle and these two are congruent, then you will have a perpendicular bisector. That's what it says right here. Then it will be a perpendicular bisector. So if CA and CB are the same, and then the line exists through such that what other pieces would be congruent? No, AC is already marked congruent, isn't it? It basically, guys, just what you're supposed to be doing is figuring out, hey, look what's congruent up here, and I bet you it's congruent down here also. What?
AD.
That AD is congruent to BD. And then that makes CD a perpendicular bisector. Remember that upside down T is a perpendicular bisector. That's the symbol for perpendicular. All right, so let's take a look at some perpendicular bisector problems. So we're going to start here with number 1. So what it's telling us is that we have a perpendicular bisector. And so when they do that, what they're telling us is that this segment that's 7x plus 4 and the segment that's 13x minus 48 are equal to each other. So that we can just make an equation out of that and solve for x. So that would look like this. That's not a 3. It's 7x plus 24 equals 13x minus 48, and so we'll solve for x since that's what it wants us to do. Subtract 7x and 13x is 6x. Add 48 to 24, it's 72, and division will give us 12. Now, looking at all of the problems on this page, they're all the same problem. They give you two pieces of information right here. You're just going to equal them. Now, on some of them, they've asked you to find RS, so you're going to have to plug your X back in. So you're not done when you find X. So 1 through 6 are basically the same problem. Number 7 is a little bit different. Okay, so what it's doing is it's asking you, does this ordered pair that's given to you, does it lie on the perpendicular bisector? So it says that you have endpoints right here. These are the endpoints of a segment. And so we'll plot those. J is 1, 2, 3, 4, 5, 6, 7, down 8. That's right there. That's J. And K will be 1, 4. And so those are Those are the endpoints of the segment. So we have a segment that is drawn between J and K. And so there's this other point L here, and they're asking you, does it lie on the perpendicular bisector? So let's point L, let's plot point L. We go -9, +2, so L goes right there. And so what I'm going to do is I'm going to draw a fictitious line. I don't know that this is the perpendicular bisector, but what I'm trying to do is I'm trying to figure out, does L lie on the perpendicular bisector? Now, again, that was just a fictitious line. I don't know that that was actually the line. So what the math that we're going to do is we're going to do some rise over run. Our boy Lucas gave us the idea that we're going to do a rise over a run to see if the distances are the same. So basically what he suggested is that we use the Pythagorean theorem to check to see if the distances are the same. Well, luckily, if we do a rise over run from J to L, and we figure that this is 10 and this is 2, and then we go do a rise over run from L to K, let's get a different color, and we go up 2 and over to K, that's 2 and that's 10, you'll see that the rise over runs are exactly the same. That those distances using Pythagorean theorem, because that's really what you're doing, is you're doing Pythagorean theorem to see if they're the same. So just to show you that, we've got 10 squared plus 2 squared will equal c squared, and that comes out to be 104. And if you did it again with the orange stuff, it'd be 10 squared plus 2 squared equals c squared, which is also 104, but those are the same. And since they are the same, the question is answered, determine if it lies on the perpendicular bisector, because these distances, 104 and 104, are the same, then yes, it does lie on the perpendicular bisector.
Action.
Okay, action. Okay, so angle bisectors. What does an angle bisector bisect? It bisects an angle, so it creates two congruent what? Angles. Okay. So what you're looking for here is that this little bitty angle here is congruent to that angle there. Okay, so it creates two congruent smaller angles. All right. So don't bother yourself with this. Don't worry about that at all. Okay. Well, I will tell you everything you need to worry about. Okay. Promise. So, what happens when you have these congruent angles, and you should know this from the triangle inequality theorem, is that the sides across from congruent angles will also be what? Congruent. Yeah. So these pieces over here are now equal to each other. And so we can make a little equation, solve for x, and boom. So we'll use blue one. 4x plus 30 equals 9x minus 5. You got it, Saji? What you got? Oh, you don't have it. Oh, you're supposed to be working it and you forgot. Oh, okay. So this is going to be 5x. This is going to be 35. I don't think 8.75 is correct. That's exactly 7. So are our algebra skills that bad that I need to go through this? Do I need to show you the algebra? Okay. We got two bad answers there, and I'm not sure where either one of them came from.
I subtracted 5 of that.
I heard an 8 point something.
Oh, I said 5.
Okay.
I just subtracted the 5 instead of adding.
All right, make sure you add to the other side. All right, so very much like, oh no, this one's different. These problems are different over here on the right. All right, so the reverse of that says is that if you have congruent sides, then you're going to have congruent what? Angles. So these over here are now congruent to each other. So moral of what you're seeing a lot of today is when you have two little expressions, they're pretty much going to be congruent to each other. Okay, so the algebra just sets them equal to each other, starts adding, subtracting to the other side, divide, and finish that out. All right, let's see how we do on let's see if we can do better on this one, right?
Yes.
I couldn't hear you.
10 equals
10 equals x? All right, let's check this out. So if I take 5 away from 8, that's 3x. If I add 41 to, what is that, 11? That will be a 30. And so x equals 10.
First one.
So as we look down at the rest of these problems, do you see any differences?
The bottom one, right, number 10 doesn't have congruence.
Number 10 doesn't what?
Have congruence.
It does. Number 10 is exactly like number 8. See, they give you the congruent angles right here. There's the congruent angles right there. So 8 and 10 are the same. 9 and 11 are the same. And then number 11 is also, that's a hypotenuse leg congruency in there. You got some congruent triangles. So those two are going to be equal as well. They're slightly different because now they start asking for the segment lengths instead of asking for just the x, right? So down here in the bottom, you're going to have to plug the value back in to finish the question. But as far as how we solve it, they're the same, right? So equal, I have to plug something in. All right, let's go check this out. All right, so that right there is the end of angle bisectors.